Welcome. Today we'll solve a complex trigonometric equation. Let's look at our equation. The sine of 4x plus sine of 2x divided by cosine of 4x plus cosine of 2x equals tangent of 3x. Let's solve this step by step. First, recall that tangent is sine divided by cosine. So, tangent of 3x equals sine of 3x divided by cosine of 3x. This means we can rewrite our equation as the sine of 4x plus sine of 2x divided by cosine of 4x plus cosine of 2x equals sine of 3x divided by cosine of 3x. Now, let's cross multiply to clear the fractions. This gives you the sine of 4x plus sine of 2x times cosine of 3x equals sine of 3x times the quantity cosine of 4x plus cosine of 2x. Let's distribute on both sides. On the left side, we get sine of 4x cosine of 3x plus sine of 2x cosine of 3x. On the right side, we get sine of 3x cosine of 4x plus sine of 3x cosine of 2x. Now let's use the trigonometric product to sum formulas. Recall that sine a cosine b equals 1/2 times the sine of a plus b plus sine of a minus b. Applying these formulas to each term, on the left side, we get 1/2 times the sine of 7x plus sine of x plus 1/2 times the sine of 5x plus sine of negative x. On the right side, we get 1/2 times the sine of 7x plus sine of negative x plus 1/2 times the sine of 5x plus sine of x. Recall that sine of negative x equals negative sine of x. After combining like terms and simplifying, we get 0 equals 0. This means our equation is an identity. It's true for all values of x where the denominators are not 0. We just need to exclude values where cosine of 3x equals 0, or where the sum of cosine of 4x and cosine of 2x equals 0. Let's verify this solution by plotting the left and right sides of our original equation. As we can see, except at the excluded values, both sides are equal. In conclusion, this equation is an identity true for all values of x except where the denominators equal 0. Thank you for watching.